Hey you guys, welcome to week 3 of remote learning. This can be some notes for lesson 7, which is just an introduction to our new unit about exponents. So as you can see, we've got exponential notation intro. You might want to put the date over here and keep yourself organized. I still suggest you keep a notebook, okay? Our target today is we want to learn how and why to use exponential notation. So we're just going to start with what we have as background knowledge, that this 3 plus 3 plus 3 plus 3, that is repeated addition, right? And so 3 plus 3 plus 3 plus 3, and you're going to have to excuse my writing with this stylus, it's always kind of icky, is 12, right? So this is kind of labor intensive, right? That takes a lot of work to write all that out. So we learn a shortcut for that, right? Because there are 1, 2, 3, 4 things that we're adding. We're really doing 4 times 3, right? And that repeated addition is when you learned about multiplication. So repeated addition is multiplication. Here we have this symbol right here is not an X, it's a multiply sign. If it's an X, we try to see it more like in cursive like that, right? So 4 times 4 times 4 times 4 times 4, right? 1,024. Another way to represent that repeated multiplication, say we used 4 as a factor, a number that we multiply by itself 5 times. That repeated multiplication is represented using exponents. So when we see it written out like this, in this long form, we say it's expanded. It takes a lot of space, right? When we see the exponent, we see that's exponential notation. And that's what the title of these notes are, right? Okay. So exponential notation for any number x, okay, and any integer, and that's for this year. You'll learn about fractions next year, n. We would say x to the n power. And all that means is take x, multiply it by itself n times. So we don't know what n is. It could be any number of times, right? So our example is 5 to the 6th power means take 5, multiply it by itself, the same number over and over. 1, 2, 3, 4, 5, 6 times. So we need to have some common vocabulary for this unit. X to the n, or x to the nth power. X is called the base, and n is called the exponent. Sometimes we hear it called the power. I will tell you that when you get to high school, though, you're going to say this whole thing is called a power. The expression itself is a power, okay? Okay, so what about parentheses? Why would we need them? Well, we know we've used parentheses before to show multiplication, right? So when we see these parentheses here, it's saying negative 4/11 times itself 4 times. 1, 2, 3, 4 factors of negative 4/11. That's different than this. This is read the opposite of 4/11 raised to the 4th power. It is like saying the opposite of 4/11 times 4/11, and those parentheses are multiply, right? And I'm going to have 4 factors of the base 4/11. And this negative is just in front of it, read as the opposite of. So translation here, if we want to repeatedly multiply a negative number, we have to have parentheses to show that that's going to get repeatedly multiplied by, okay? So here, 5 to the 6, 1, 2, 3, 4, 5, 6 factors of 5. We're multiplying it by itself 6 times. It's not 5 times 6, right? That would be if we were adding 5 together 6 times. Okay, 5.3 raised to the third power means 3 times I'm going to take 5.3 and use it as a factor times itself. So 3 factors of 5.3. Really going to get used to the word factor before next year, okay? All right, last one here. If we multiplied -7 times itself 4 times, we would do this. A base, -7 to the 4. Now, as I've written it, that's the opposite of 7 to the 4th power. I want to make sure that the -7 is what's getting multiplied repeatedly. I have to use those parentheses. Super duper important, okay? Okay, so if we close this, why would we bother? Why do we even do this? What do you think the advantage is it? Well, think about when you learned multiplication. What was the advantage, right? Well, it saves a lot of space for writing, doesn't it? So it saves us space on our paper. And it's also going to save us time, save space and time. The other thing is it's just easier to read. I don't want to count all those out and figure out how many times. Why don't you just tell me how many times using an exponent, right? Okay, so important part here then, see if I can get you a little highlighter on this, is for any number x and any whole number n, this is going to be our base, our factor. What are we multiplying over and over? This is going to be how many times we do. Okay, so this is just in general what the notes were about, right? Now, I think we kind of get this already because we did it when we were doing our last unit with Pythagorean theorem a little bit and solving for squares and all that, all right? So let me write down just real quick here. Base, I spelled it wrong, right? And exponent. Okay, if you need a little break, this would probably be a good spot to take it. If not, I am just going to continue on to our next page, all right? We're just going to do some samples together. We aren't going to do all of this together, okay? But if we write each expression in an exponential form, well, what form is it given to us again? This is expanded. So what are we multiplying? 6, that becomes the base. Oops, sorry about that. We'll do blue. Okay. This is our base. How many factors are there? 1, 2, 3, 4, 5. That's the exponent. Okay. And they asked us to do exponential form. They're not asking me to give that as a value, like actually do that math. Here, exponential form, 1, 2, 3 factors of a base of 9 over 7. Here, because it's a fraction, I am going to put that in parentheses to show that both the numerator and the denominator are getting multiplied by each other, okay? 1, 2, 3. Instead of writing it out 15 times, let's just say we take 4 and multiply it by itself 15 times. It's not 4 times 15. It's 4 times 4 times 4. We multiply it by itself 15 times, right? Okay, for D, this is the one we have to be really careful of. We have to use those parentheses when we have a negative. I don't think I can say that enough. All right, you have to put parentheses if you want to multiply a negative repeatedly by itself. Same thing here, we got a negative fraction. Even if we didn't have the negative there, I think with a fraction you should get used to those parentheses. Okay, 1, 2, 3 factors of negative 2/3. 1, 2, 3, 4, 5, 6 factors of x. 1, 2, 3, 4, 5, 6, 7 factors of 1 over x. Okay, it's not 7 times that. I'd just say 7 times 1x then, right? Okay, so here we have a little bit of something different because now we have some different bases. So the 2 is getting multiplied by itself twice. times the 3, which is getting multiplied by itself 3 times. Now, if we were going to follow order of operations, what would we do first with PEMDAS? We would do the exponent, and then we would multiply these. Okay, same thing over here. Base of 11 used 3 times a base of x, which was used twice. And in this case, I probably don't even need that dot, right? Okay, over here, how many factors of x? X is a base, multiplied by itself 3 times. Y, multiplied by itself once. We're going to talk about this in just a minute. All right, 1, 2, 3 factors of a. A to the 3rd power. 1, 2, 3 factors of b. See, I'm not going to put that dot in like I did up there. 3 factors of b. 1, 2. 2 factors of c. Okay, last one. R used as a multiplication over and over factor. Oops, I'm so sorry. 20 times. And Q 9 times. Okay. All right, actually I got to kind of be able to see these right now. So if we look at this problem, what exponent does the variable y have? How many times was it multiplied by itself? Once. But you notice I didn't write it up there. This is something we didn't really get too much time on, and we would have. This would have been a good point to do it, but I had a poster on the wall called Invisible Math. But the positive 1 here on this means 1 factor of y, and it's just kind of invisible. It's kind of like y, well, is also 1 times y. Y is also y over 1. Y is also y to the 1st power. We just don't write all that. It's assumed. You know, it's there. We just don't write it. It's kind of invisible math, we call it. It's just not necessary, okay? All right, look at the parentheses for D and E. Oops, sorry. Okay, sorry, D is here and E is here. Okay, why are we doing that? Okay, why? We need to do parentheses if we have negative numbers. So negative base. I'm sorry, it's really sloppy. A negative base or a fraction. I keep thinking that I'll get better at this handwriting, but I'm not. Okay, we are not going to do all these because I think we'll get the hang of it here. But let's read it. This is negative 3 squared, not the opposite of 3 squared. Negative 3 squared. It means negative 3 times negative 3, 2 factors of negative 3, which is equal to 9. Now, this is the value out of it. We've evaluated it over here. Evaluated. Okay, so negative 3 to the 3rd means negative 3. Oh my God, I can't believe I'm getting this. Sorry guys, let me get back to crazy. Stay with me. Negative 3 times negative 3. Negative 3, just lost all my mojo with that, which is equal to negative 27. So I've done these before. I would guess that if you were doing this on your own, you'd have your own calculator. Okay, but I want you to think about what you learned when you were multiplying integers. Okay, this is going to be equal to 81. I think you get the idea here. 1, 2, 3, 4, 5 factors of negative 3. Oh my God, stop. You know, guys. Which is equal to negative, sorry, I lost my pen now. Negative 243. 6 factors, I'm going to give you, would be equal to 729. 7 factors of negative 3. All right. So it's not this so much I want us to look at. I want us to look at the value here and the pattern that we should see. Okay, so what do you notice? I hope you notice. Right, I hope you see it. right? And again, depending on how your teacher last year taught you exponents and multiplication, hopefully you're noticing that when we had an odd number of factors, that is an odd power, right, or odd exponent, odd ditto number of, I should say, on the exponent. Then our answer was, sorry, not odd, but negative, right? Now I don't have time to write this here, but, you know, clearly then if we had an even power up here, or exponent, we would have an even number of negative signs, and that would give us a positive answer, right? So that will be really kind of a big deal next year for you, okay? Just saying. I wish I could stop this from happening. I'm really, really sorry. I'll try to figure out that next time. Okay, so we're just going to talk about this one here. It's saying it, right? We seem to have the same numbers going on, but this parentheses make a difference, right? This is the negative 4 squared. That's negative 4 times negative 4. Those parentheses are there to show that I'm multiplying a negative times itself, whereas this is the opposite of 4 squared. So this is going to be 16, whereas this is going to be negative 16. Okay. Now, if we look down here, negative 4 times itself 3 times. It's 64, right? No. Right? Here, the opposite of 4 times 4 times 4. Well, there, it didn't matter, did it? So it mattered a lot up here, right? We had an even number, an odd number of negatives versus the opposite of something cubed. That's just something to be aware of. If we want to raise something to a power that's negative, that base needs to be in the parentheses, okay? Okay. Hopefully that wasn't too overwhelming. You've got some practice to do before this and a little bit of a quiz also. Please make sure you're getting in contact with me if you have any questions. Usually the best place to do that is at Microsoft Teams, okay? All right, bye guys.